Compounds can form in a couple of different basic ways. We're going to talk about the difference between an ionic bond and a covalent bond. Basically, it comes down to ionic being based on plus-minus attraction and covalent being based on shared electrons. But we'll see that in a second. First, an example. Ionic looks like this. I've got a sodium ion and I've got a chloride ion. This plus and this minus want to cancel each other out. Specifically, they have an attraction between them that's just a normal old attraction between a plus and a minus that you've heard about since you were in grade school. So pluses and minuses attract one another, and this plus-minus attraction makes them stick together. So they stop being a separate Na plus and Cl minus, and they start being just a single bonded together thing that's called sodium chloride, NaCl. Well, what about covalent? I can't talk about covalent bonding between these two because that would be a metal and a non-metal, and that's always ionic, right? You do know that. You definitely do know that. Covalent would be, say, if I have an oxygen and I've got two, tell you what, I'll use a different color. An oxygen and two hydrogens. Now, you know this is H2O, right? Please say yes. So the oxygen, if you look at it in the periodic table, I look at it over here and I see that it is in the first, second, third, fourth, fifth, sixth column. Am I right? So sixth column means that it has 6 electrons around it. 1, 2, 3, 4, 5, 6. And then I go back to the periodic table and I look at the hydrogen and, oh, it's right there. That's nice and easy. It has just 1 electron. I will write it in green. Please be the same color green. Yeah, sure. 1 for each hydrogen. Now, let's take stock of what we've got here. I've got these 2 electrons here and these 2 electrons here that are both shared. They're actually on both the oxygen and the hydrogen. So think about it. Remember the octet rule? That's a fancy name for atoms want 8 electrons, right? Look at these. Does the oxygen have 8 electrons? Count around it. 1, 2, 3, 4, 5, 6, 7, 8. Some of them are shared, but that's fine. It does have its 8 electrons and everything's happy. Hydrogen is the one special one, where it being over here means that it's happy with just 2 electrons, because it only needs to get to the end of the first row. So hydrogen's happy with 2, and let's look at it. 1, 2 for that hydrogen, and he's happy. 1, 2 for that hydrogen, and he's happy. So the O's have 8, the H's have 2 each, and everybody happy. Big party. Right? Well, I mean, don't get too excited, but the fact that everybody has the right number of electrons means that everything is stable, and stable is what everything is all about. So these are shared electrons. There are no plus minus attractions. It's all based on these shared electrons. So the big difference between them is that ionic is based on the plus-minus attraction, there's no diagram of electrons, right? But when you want to draw a picture of a covalent situation, you always focus on the shared, and there is no, I'm trying to underline down here, no plus-minus attractions. That is the difference.